Good morning. Today we're going to take a look at global wind and pressure belts. One of the most important things to understand climate is knowing where there's high pressure and low pressure commonly, and knowing which direction your weather comes from. So we're going to put pressure belts over here and wind belts. We're going to label those over here. And winds are driven by differences in pressure, and differences in pressure are commonly from differences in how the Earth is heated. Along the equator is where the Earth is heated the most, and I'm going to shade that in. This belt around the equator is called the Doldrums, Doldrums. This is an area of rising air, so I'm going to draw arrows going up away from the Earth. Imagine you were looking at the edge of the Earth, that thin layer of atmosphere. The air rises there and makes clouds. That's low pressure. I'm going to put an L inside a cloud to remind myself that's a band of clouds. Commonly when astronauts look back at the Earth from the moon or from space, they see a belt of clouds. And in general, the equator is a cloudy area, lots of precipitation, and it's warm. So that's where we find most of the world's rainforests, whether it's South America, Africa, or Indonesia. Now, that air that rises here cools off, and it returns to Earth at what's called the horse latitudes. And since it's pushing down on the Earth, it's high pressure, and we remember that high pressure is usually sunny skies, clear skies anyway. And I'm going to switch colors here because this is a belt that's not cloudy. This is a belt of clear skies. And we're like right on the edge of the tropics, 20 to 30 degrees latitude or so. So it's still hot. And if we have hot temperatures and very little precipitation, because this area is dominated by high pressure, we would expect the arid climates, like deserts and in fact, that's what we find here in Mexico. That's pretty dry. That's a desert. Here in North Africa, that's dry. That's a desert. And the same is true in the southern hemisphere. So those are two pressure belts. It's pressure that makes wind blow, and wind blows from high pressure to low pressure. Now, because the Earth is spinning, we're a rotating sphere, because it's spinning, winds, they blow from high to low. So on the surface, they blow right from that high to that low. But because the Earth is spinning, there's something called the Coriolis Effect. And that causes objects moving in the northern hemisphere to veer to the right. So that wind starts at the high and is headed towards the low, but it's curved to the right. Starts from the high, heads to the low, but curves to the right. Now, looking at this, you may say, but Mr. Cody, those are going to the left. They're going to my left, but you have to imagine you are the wind, and the wind is curving to the right. Imagine you're riding that wind. If you were the wind, you'd be curving to the right. And that's what I mean by objects in the northern hemisphere veer to the right. This belt of winds between between the doldrums and the horse latitudes are called the trade winds, because trading vessels took advantage of that to come from Europe to the New World. They would drop down and ride the trade winds across instead of bucking the wind the whole way across. Okay, so we've got the doldrums, that's a low pressure. Horse latitudes, that's a high pressure. Around 60 degrees north latitude, I'm going to switch colors again. There's another belt of low pressure, and I'm doing Red and blue, you could be using whatever colors you have, but just the pattern should be the same. So this belt at about 60 degrees latitude, kind of like by the Arctic Circle, that is another area of low pressure. So it's rising air and clouds. And we call that the polar low. Not nearly as cool of terms as closer to the equator. And winds still blow from this high to this low. Here they blew from high to low, curved to the right. Now they blow from high to low and curve to the right. We're still in the northern hemisphere. And this belt of winds is called the Prevailing Westerlies. And that's where we live. And that's why our weather comes from the west. In general, between these two latitudes, between the horse latitudes and the polar low, air masses move from west to east. Weather patterns move from west to east. So we can look to the west to get our weather. Europe looks out over the Atlantic. That's the weather that comes their way. If we were further south, say in Mexico, Mexico gets their weather blown by the trade winds, and it comes from the east. And these shift northward in the summer and southward in the winter. So places that are right on the fringe, like Florida, Florida is more likely to get weather from the east in the summer because they're more on they're on the edge, but they're more likely to get trade winds in the summer. In the winter, they're more likely to get prevailing westerlies. So like hurricanes in the summer, hurricanes develop here, get blown across the ocean, pushed by the trade winds, and then sometimes they get far enough north that they hit the United States. If they get too far north, then they get blown back out when the prevailing westerlies start pushing that system. Where are we at? Polar low around Santa's, I want to be that, I want to be blue for that. Around Santa's workshop at the North Pole is another system of high pressure called the Polar, I probably should have kept this in red just to be consistent, called the Polar High. And it's an area of clear skies, not necessarily sunny, because at the North Pole it's dark much of the year, half the year. But it's an area dominated by high pressure. Even though we see Santa with boots on and snow all around him, he doesn't get much snow. A couple of inches a year. It's just that it's so cold it doesn't melt. So it's a very dry climate, although it's cold. And winds blow from high to low across the surface. I forgot to draw in this high to low, and returning air aloft. Returning air aloft. We've got complete convection cells. Remember when we talked about magma? We said hot magma rises, cool magma sinks. That's what's happening with this air. This is a convection cell. At the equator, the hot air rises, creates clouds, moves aloft and cools and sinks. As it sinks, it heats back up. But because it's dry air now, it heats up even more than it cooled off. And it gets a little complicated, but this is still an area of hot air. Here the air rises and cools and makes clouds, and that air circulates aloft and then comes back to Earth at the high pressures. We're missing some winds here. Winds blow from high to low, but in the northern hemisphere, I'll go back to blue, they curve to the left. Curve to the left. I didn't really have to change colors with the winds because winds are winds. Winds blow from high to low and curve to the right. I'm sorry, I said left. To the right in the northern hemisphere. Curve to the right. Curve to the right. But remember, you have to put yourself in the wind's perspective for that to make sense. That if I was the wind, I would be curving to the right, not how you look at it. And this belt of winds is called the Polar Easterlies, because they're coming from the east. Winds are always named for the direction from which they come. So these east winds are coming from the east, west winds are coming from the west. And that's the winds in the northern hemisphere. Southern hemisphere, the layers are the same. We have a layer of trade winds blowing in this direction. We have a layer of prevailing westerlies coming from the west, and then polar easterlies coming from the east. The doldrums are already in both hemispheres because they are like 5 degrees north and 5 degrees south of the equator. But then we have another belt of high pressure called the horse latitudes again, and then we have another belt of low pressure called the polar low, and another belt of high pressure called the polar high. So if you could flip this down, if you could just flip that over, it would be a copy. But keep in mind, in the southern hemisphere, these winds blow from high to low, but curve to the left. From high to low, but curve to the left. From this high pressure to this low pressure, but curve to the left. So finish up for the southern hemisphere. The labels are the same. Everything you have in the northern hemisphere, you should have in the southern hemisphere. Have fun. Thanks.